In this next lesson, we're going to discuss how we can develop formulas for circles and also regular polygons. Okay, so we're going to look at some prerequisite skills in the warm-up here. Okay, obviously they should help us out with what we're doing today. So it tells us to find the unknown side lengths in each special right triangle. So in number one, we have a 30, 60, 90 triangle with a hypotenuse of 2 feet. And we're expected to find the short leg and the long leg maybe. So I'm going to start here by just drawing out our special right triangles. Okay, so I'll do my short leg here, do a long leg, and our hypotenuse. Again, these aren't going to be perfect, but that's all right. I'm going to say this is my 30-degree angle, this is my 60-degree angle, and obviously this is my 90-degree angle. Okay, and we have to remember the side opposite the 30 has the ratio of 1. Opposite the 60 has radical 3, and the hypotenuse has 2. Okay, and while we're at it, we may as well draw our 45, 45, 90 triangle here as well. Okay, so again, this is a right isosceles triangle, meaning that these two legs are the same length. And we have our right angle right here, so that makes this a 45-degree angle. This is also a 45-degree angle, and there's our 90-degree angle. Okay, and the side opposite the 45s both have that ratio of 1, and then the hypotenuse will have that radical 2 ratio. Okay, and so in the first one here again, it asks us for a 30, 60, 90 triangle with a hypotenuse of 2 feet. Okay, well this is exactly what we drew out here. Okay, with the green triangle. So the short leg here would have a length of 1, and the long leg would have a length of radical 3. So I'm just going to write that down. Okay, short leg. Short leg equals 1, and then I'm just going to write that the long leg is going to be equal to radical 3. Okay, so pretty simple there. Okay, if we know how to draw these special right triangles. Okay, let's take a look at the next one. Number 2 says we have a 45, 45, 90 triangle, and it's got a leg length of 4 inches. Okay, now there's many ways that we could actually figure this out. Okay, but let's maybe just do a proportion maybe. Okay, I'm actually just going to draw another right isosceles triangle here. Okay, this time our leg length is 4, right? So we know that these are both 4. Okay, so we could use the Pythagorean theorem if we wanted to. We could also just call this x and solve by proportions, and let's maybe try that. Okay, so I'll compare the one of the legs here. I'll call this as a 4:1 ratio. If I'm going the leg of this new triangle to the leg of the ratio, or the length of the ratio. Okay, and that's going to be equal to the hypotenuse to the other hypotenuse, which is radical 2. Okay, and so at this point I can just sort of use the cross products property here. Pretty simple, and I could get 1 times x is x, and then 4 times radical 2 is 4 radical 2. Okay, so I could say therefore the hypotenuse equals 4 rad 2. Okay, and I guess that would be my answer here. Maybe I should go back and circle my other answers in this other one, so we kind of know what we're talking about. Okay, and let's look at the last one. Okay, this is now a 30, 60, 90 triangle with a longer leg length that is 3 meters. Okay, this gives me a good reminder. I should really go back and attach units. Okay, let's just go back and call this feet, radical 3 feet, 1 foot. Okay, and so I'll go ahead and maybe draw my new triangle. Really pretty easy, but I'm just going to go ahead and draw my 30, 60, 90 triangle. Okay, remember this is just like the green one up there. Okay, except now I have a different longer leg length. This one's now going to be 3. Okay, and just I'm just going to call this one maybe like x and y. Okay, and I'm just going to solve this by proportions. Okay, so maybe I'll just compare like the shorter leg of the triangles first. So I'll maybe say this is like an x:1 ratio, and then I'll compare the longer leg. Okay, so these ratios should be equivalent. So the longer legs here would be a 3 to radical 3 ratio. Okay, and so what I end up with here when I use the cross products property is I'll get radical 3x is equal to 3. Okay, I then have to divide both sides by radical 3, so I get x equals 3 over radical 3. And now I have to go through that process of rationalizing the denominator. So I'm going to multiply both the top and the bottom by radical 3. Okay, this will now give me 3 times radical 3 over 3. Okay, and when I go ahead and simplify, I can see that my final answer will just be x equals radical 3. Okay, so that would be, again, the shorter leg. So I'm going to call this the short leg. Okay, and now I have to go and figure out my longer leg. And I'm going to change colors here to blue so I can sort of keep this separate. Sorry, I already know the long leg. I want to know the hypotenuse. Okay, so maybe I'll compare the hypotenuse of y to the hypotenuse of our other triangle, which we know has a ratio of 2. So y is to 2 as, let's say, 3. We know that longer leg of the red triangle. And then it's going to be radical 3 for the other one. Okay, so similar process here. If I go ahead and multiply the cross products property, I'll get radical 3y equals 6. Okay, I'll divide both sides by radical 3 here, which will now give me y equals 6 over rad 3. And then I'll multiply both the top and the bottom by rad 3. Okay, which will now give me 6 rad 3 over 3. And then the 6 divided by 3 just gives us 2. Right, so this should now be 2 radical 3. Okay, and this is, again, this is now going to be our hypotenuse. Okay, so our hypotenuse equals 2 radical 3. Okay, and so that kind of makes sense, right? You know, some of your other teachers may have said before, well, the hypotenuse has to be double the length of the short leg. Okay, well, our short leg was radical 3, now our long leg is 2 times radical 3. So all that actually makes sense. Okay, remember I told you that there are several ways that we can actually solve that problem, and one of them is just using proportions. Okay, so let's look at what we're studying today. Okay, today we are going to develop and apply the formulas for the area and circumference of a circle, and we're also going to develop and apply the formula for the area of any regular polygon. Okay, some vocabulary that we'll want to be familiar with today will just be a circle, so we'll get a good definition of that. Okay, we'll talk about, you know, how a circle, how we use that in our language of geometry. Okay, we'll talk about how, you know, we have a center of a circle and a center of a regular polygon. We'll talk about this new thing that we may not have heard of before called an apothem. And then we will discuss kind of the central angles of regular polygons. Okay, so in the next video, we'll go ahead and get started.